Hey, it's Jillian. We're going to take a look at special products. So when we're squaring out a binomial, so let's see what that looks like. First of all, you know this is the same as this because, of course, anything times itself is that thing squared, right? So let's see here. If I have x plus 4 times x plus 4, I'm going to get, when I multiply out my brackets, x squared. That's 4x plus 4x is 8x, and that times that is 16. Here, this is the same as 2x plus 3 times 2x plus 3, and that's 2x times 2x is 4x squared. That's 3 times 2 is 6x, 6x plus 6x is 12x, and then I've got 3 times 3 is 9. This here is 3x minus 2 times 3x minus 2. And when I square those brackets out, I've got 3x times 3x is 9x squared. That's minus 6x, and minus 6x is minus 12x. And that times that is positive 4. And then here, I have 5x minus 3y, 5x minus 3y. And now I've got 25x squared. That's minus 15xy. Minus 15xy is minus 30xy. And then positive 9y squared. So, do you see a pattern? Well, I'm going to point out in math what I just kept saying, which is you square the first, then you do this times this, and you double it, right? I did 15xy and 15xy. I did 6x and then 6x. Again, I did 4x and 4x. The middle two terms are the same when you have a binomial square or a binomial times itself. So there's sort of a shortcut that we can use here, which I'm going to talk you through. Basically what it looks like is this. To go from here to here, the only difference with the positive and negative is the middle term is the sign in the bracket. Because, of course, when I did negative 3 times negative 3, the last term ends up to be positive, whether it's a negative or a positive in here. Because a positive times a positive is a positive, and a negative times a negative is a positive. So the only difference will be if this is, whatever's in the bracket is the sign of the middle term. So let's see here. I've got y squared. I've got this times this doubled. So what's y times negative 7 is negative 7y. And double it is negative 14y. And then square that. Negative 7 times negative 7 is positive 49. So you can go straight from here to here without doing this middle stuff. Let's do another one. That squared is 9x squared. That times that doubled is 12xy, and 12xy doubled is 24xy, and then that squared is 16y squared. Okay, let's do another one. First I'm going to leave that 2 out there, and I've got that squared. That times that is negative 7ab doubled is negative 14ab. And then that squared is positive 49b squared. But don't forget I've got that 2 there, so now I have to distribute that 2 in, which is 2a squared minus 28ab plus 98b squared. Okay, so now what we're going to do is we're going to look at the answer and see if we can write up the question. So here they're saying, which one of these is a perfect square binomial? Which of these, right? So when I look at this, this is what I do. I say the square root of this is half of that. So square root of that is 4 and half of that is 4, and 4 is what goes in the brackets. It's really as simple as that. So let's take a look here. The square root of that is 7. Half of that is 7. So this is x plus 7, because remember, whatever is in front of the middle term is what goes in the brackets. Here, let's see this. What's the square root of that? 10. Is that cut in half? Is that 10? No. So this is not no. In fact, if we were asked to make this a perfect square trinomial, what it would be is half of that is 10. I'm sorry, square root of that is 10. And half of what number is 10? 20. Now it is a perfect square trinomial. And the answer would be x, that sign. And the square root of that, or half of that, was 10. And that's how you do special products. Little shortcut. So let's do a little bit more, because now we have a different kind. There's two parts to the special products. Special products for sum and difference are this. Here you'll see they aren't the same. In fact, they're almost the same, just the signs are different. So let's multiply these out and see what we get. So x times x is x squared. Then we have minus 4x plus 4x minus 16, which equals, those cancel out, so we've got x squared minus 16. Let's do this one. 4x squared minus 6x plus 6x minus 9. Those cancel out, and we're left with 4x squared minus 9. Now let's take a look at this one. 9x squared plus 6x minus 6x minus 4. Those cancel out, and we're left with this. I think you get the idea. So what's the pattern? The pattern is that when you have a product of two binomials and the only thing different is the sign, what ends up happening is the answer is the first one squared minus the second one squared. Let's take a look. The first one squared, x squared is x squared, and the second one squared, 4 squared is 16, with a negative sign. There's always a negative sign. 2x all squared is 4x squared, 3 squared is 9. 3x all squared is 9x squared, 2 squared is 4. So this will be 25x squared minus what's 3y squared? It's 9y squared. So now let's go straight to the answer for these ones. This squared is that minus this squared is that. All we have to do is check that everything's the same in the brackets except the sign. So now we've got that first one squared minus the second one squared. Here we go. Everything's the same except the sign, so we've got the first one squared minus the second one squared. All right. Now let's take a look here. We're going to do the same thing we did on the previous page, which is they'll give us the question. We have to figure out the answer. We have to figure out the question. So here, is this a difference of two terms? So here, this is absolutely the difference of two terms, right? This is going to be x minus 3, x plus 3, right? Because this is x squared, the middle terms cancel out, and then negative 3 times positive 3 is negative 9. Here, this is a perfect square, a difference of two squares. It's just that this is a root, and we kind of don't do that till grade 11, so I'm going to skip that right now. And then here, this is not a difference, this is a plus, so this is not something that can be factored at all whatsoever. However, if it was this, minus 25, then we would say it's x plus 5, x minus 5, because 5 times 5 is 25, and x times x is x squared. And that is our section on special products.